In this video, I'll show you how to calculate the exact yield to maturity of a bond in Excel. The yield to maturity is the rate of return of the bonds, reflected by the letter R in our formula. In our example, we know what all the components of this formula are except the yield to maturity. We know that the par value is £1,000, the coupon rate is 6%, there are 5 years to maturity, and the bond's price is £950. Before we calculate the yield to maturity, we must first calculate the annual coupon payments. We're assuming that interest payments are annual, therefore the coupon is the coupon rate multiplied by the par value. If we were to enter the inputs we currently have in our formula, it would look like this. Now, one way to calculate the value of R, the yield to maturity, is to use an approximation. Another way is through trial and error. However, what we want to do is find the exact value of the yield to maturity without any manual effort. To do this, we can use Excel's rate function, which is a function that returns the interest rate per period. So we type equals rate. First, it's asking us for the number of periods, which is 5. We then need to input the payments, which is the coupon payments we calculated earlier. Next, we enter the bond price. However, make sure to add a negative sign first. This is because the bond price is a cash outflow. In other words, we're paying £950 upfront and receive future cash inflows of £60. Finally, we input the par value, which is a cash inflow, and as a result, we can keep this positive. When we click enter, we can see that Excel has calculated that the yield to maturity is 7.23%. In other words, the value of R is 0.0723. But how do we know that this is correct? Well, let's double check by creating a calculation table. As per our formula, we'll receive just the coupon in years 1 to 4, and in the final year, we'll receive the coupon plus the principal. So let's input the coupon payments and add absolute references to ensure this remains static as we drag it across. Then in the final periods, we'll add the principal to the coupon. Next, we need to calculate the present value of each of these coupon payments. We can calculate this by taking the coupon payments and dividing it by 1 plus the yield to maturity that we calculated earlier to the power of the current year. Now, once again, make sure to add absolute references to the yield to maturity to ensure this remains static. Now that we have all the individual present values, we can add these up to give the price of the bonds. Here we can use the sum function. As you can see, this returns the exact same bond price as the one we used to calculate the yield to maturity earlier, which confirms that 7.23% is indeed correct. So that's how you can calculate the yield to maturity of a bond with annual coupon payments. In the next video, I'll show you how to do the same for a bond with semi-annual coupon payments. Please give this video a thumbs up if you found it useful, and subscribe to the Excel Hub for weekly Excel tutorials, techniques, and examples.